Okay, dear students, let's learn how to maximize objective function with the constraints into the dual form. How to convert the maximize objective linear programming model into the dual form. So what is the dual form? Dual form is converting the model linear programming problem into the dual form so that we can find optimum solution in another way. You may verify your solution through the graphical method and the other way, simplex method and the other way. Okay, let's begin. Remember, in the dual form, we change all these symbols. Z has to be converted, x1, x2, x3, x4, whatever would it be, all has to be converted. So the objective function from the maximize, it has to be converted into the minimize one, the minimization one. It will become the minimization one. What does that mean? It means the maximization of the profit. It is maximization of the profit with the decision variables. It is maximization of the profit. So minimization of the cost is also maximizing the profit, and maximization of the utilization of resources also give you the maximum profit. And through minimization of the cost, you also get the profit, maximum profit. So that is why this is the logic behind it. Okay, let's solve it. So x1 would be y1, and x2 would be y2, and x3 would be y3. You see, x1 would be y1, x2 would be y2, x3 would be y3. You see, these coefficients has to be changed. 6 will not be its coefficient anymore. Instead, 6 we will be using the first constraint, and the second constraint we use the right hand side of the first constraint, that is 24. Okay, and for the next coefficient of the objective function, we will use the right hand side of the second equation, that is plus 30. And you see there is no constraint for this, so we will write 0. So what does that mean? It means it is same. So this will be our objective function, minimization objective function in the dual form. Now, it's important that we check it whether it is in the canonical form or not. If it is not, then it will be a problematic for us. For example, in the maximization one, you see the inequalities must be less than. If it is greater than, they have to be converted. Fortunately, they both are in the less than, so we don't have to convert it. How do we convert it? We convert it when we multiply minus on both sides, this side and this side as well. When the both sides will be multiplied, the inequality will be inverted. It will be from the less than to the greater than. Equal to will be same. So let's move ahead. So canonical form, it is already in the canonical form. The canonical form has to be ensured. Just to mention that you don't miss it out. Okay, let's talk about the constraint. We need to develop the constraint as well. But for the constraint, you need to see the coefficients. What are the coefficients? 4 is the coefficient of the objective function. 4 is the coefficient of the first constraint. 4, 1, 3. 4, 1, 3. Nothing is written, it means 1. Second, 2, 6, 3. 2, 6, 3. So this is done. So we have to develop a matrix with that. Now we have to transpose it. So in the transposition, what do? We convert the row into column or column into row. It's over you. But I prefer the row into column. So 4, 1, 3, 2, 6, 3, 2, 6, 3. It is transposed. It is transposed. It is transposed. Now, the coefficients are there. The coefficients are ready to go. You see, every coefficient we already know the variables are y1, y2. So y1 plus this plus sign has to be mentioned. You need to be careful about the signs. And inequalities must be changed since it is the minimization problem. It was the maximization. So inequalities has to be converted into less than 2, greater than equals to. Okay. There you see there is no y3. You may write plus 0 y3, but there is no need for it as such. I'm just mentioning for your understanding. And in the right hand side, instead of 24, you have to write 6. To write 6. Instead of 24, you have to write 6. So this first constraint is ready, is done. Now let's talk about the second constraint, that is 1y1 plus 6y2 plus 0y3 greater than equals to, instead of 30 you have to write 2. This is also done. The last constraint, you see constraint were 2, now the constraints are 3. Constraints are 3. So you see third constraint would be 3 y1 plus 3 y2 plus 0 y3 greater than equals to. You see we have the third, you see we have the objective function over here. So 12 would be its constraint. So just let me reiterate. Instead of right hand side of the constraint, we took the coefficient of the objective function, that was 6, 2 and 12. Okay. Signs are changed, variables are changed, coefficients are changed. Okay. So now the constraint would be 4y1 plus, you may also write them like this. 4y1 plus 2y2 then equals to 6 y1 plus 6y2 equals to 2, 3 y1 plus 3 y2 plus no plus equals to 12. So you see coefficients from constraints from the 2. If we had the 2 constraints over here, now the constraints are 3, 1, 2, 3, and the objective function is has become which we already took it out. I'm just rewriting it. So this is the dual form. Thank you.